Alright guys, so hopefully this is a bit of a review and this video can go pretty quick, but make sure you take pretty good notes and you are following along. Alright, so the number one exponent rule is that I can never, ever, ever have a negative exponent. It doesn't matter where it is in the problem, whether it's in the denominator or numerator, I can never have a negative exponent or power. So the trick to making it go away is that anything to a negative exponent is equal to 1 divided by that same thing. So I want you to notice something here. The negative went away. So the fact that I crossed it over the equal bar, the division bar right there, the negative power went away and I just got left with the number that it originally was without the negative sign. Okay, so this works for just numbers. So look here, I have 2 to the negative 2 power. That's the same as 1 over 2 squared, which is equal to 1/4. If you don't trust me, go ahead and put in your calculator. I bet you get the same thing. All right, and a power to a negative exponent just is the same thing, 1 over b to the 7th. And then I want you to notice here, if you start with the negative exponent on the bottom, it still does the same thing. It has to cross the fraction bar, and then it will become positive. So it's that over 1, but normally we don't write it over 1. We just write it without the 1 denominator. So whether it's on the bottom or the top, whenever it crosses the fraction bar, it becomes positive. All right, the next property we're going to look at is adding and multiplying exponents. So hopefully this is a bit of a review. But whenever you are whenever we are multiplying, we're actually adding exponents. So if you see here, x to the a times x to the b is going to be x to the a plus b. And this makes sense, right? Because if you think of x squared times x squared is x to the 4th. Or x squared times x cubed is x to the 5th. Now, if it's hard for you to kind of visualize this, I want you to imagine, like here, 2 squared times 2 cubed, it's the same as saying 2 squared means 2 times 2, right? And then 2 cubed means 2 times 2 times 2. Well, I want you to count it up. How many 2's do I have? I have 1, 2, 3, 4, 5. So if I have 5 2's, that means that's 2 to the power of 5. Now, instead of doing that long process, I can just add the exponents. So 2 squared times 2 cubed, I add 2 and 3, add 2 and 3, and I get 5, which simplified is 32. Same thing down here. If I have 6y's, so 1, 2, 3, 4, 5, 6, and 7y's times 7y's, 1, 2, 3, 4, 5, 6, 7. Counting those up, what do I get? I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 y's. So that's y to the 13th. I have 13 y's. Well, look, if I just do 6 plus 7, I get 13. So I can cut out that middle step there. Now, when multiplying exponents, so whenever I have something in parentheses to a power, it's actually multiplication that is going on, okay? So when you're multiplying here, you're adding. When you're multiplying with parentheses or you have a power to a power, you're multiplying, okay? Now, hopefully this makes sense because we did a little bit of this when we were factoring. Like if I had x squared cubed, we looked at how that was x to the 6th, right? Because 2 times 3 gives me 6. So here, 3 squared cubed is the same as 3 to the 2 times 3 power, so 3 to the 6, which is 729. Or m to the 6th power times 4. 6 times 4 gives me 24. Now, hopefully you can see also why this works, because remember, power means I have that thing 4 times. Well, m to the 6 times m to the 6 times m to the 6 times m to the 6. That's m to the 6 to the 4th power. If I follow the rule up here, I get m to the, and I have 6 plus 6 plus 6 plus 6, 6 plus 6 plus 6 plus 6. And if you simplify that, that's m to the 24th power. So you can see how the addition and the multiplication rule kind of go hand in hand with one another. Just make sure that whenever you are multiplying two things with the same base, I want you to also notice that 2 and 2, right? Y and Y, X and X, they have to have the same base. Then you add the exponents. Whenever I'm multiplying and raising something to an exponent, then I'm multiplying the exponents, okay? So a power to a power means multiplication. All right, so doing a little practice here, adding these exponents. So I have x to the 4th times y to the cube times x times y to the 7th. So my like terms here are these guys. So that's going to be x to the 4th. The power on this guy is just 1, so when you don't see it, it's 1. And then I have y to the 3 and 7, so that's 3 plus 7. So that will simplify to x to the 5th, y to the 10th. Okay? Now you don't have to do this in between step. I'm just showing you what's going on. All right, the second one, I have m to the negative 4th times m, p to the 3rd power times p to the z power, p to the 7th power, and z. Nothing else has z with it. So I'm going to do these guys first. So m to the negative 4 plus, remember this guy has a power of 1, p to the 3rd power plus 7, and then I have that lonely z. So that's going to give me m to the negative 3rd power, p to the 10th, z. Now, you may think we're done, but we're not, because remember, we don't like negative exponents, so that guy needs to hop to the bottom of my fraction to become positive. So he's just going to hop to the bottom. He stays 3, but now he's positive, and that would be my final answer. All right, so now doing some examples with multiplying exponents. It's kind of like distributing, so you can think of it as distributing the exponent as long as there's only multiplication going on inside of the parentheses. So distributing those guys, I'm going to get j to the 2nd power, k to the 7 times 2 power, which will simplify to j squared, k to the 14th. Okay? And that makes sense, right? Because remember, jk to the 7th to the 2nd power means jk to the 7th times jk to the 7th, which remember, I add exponents, so that's j to the 2nd, and adding 7 and 7, I get 14. So I want you to notice that writing it this way, writing it twice, or just multiplying the exponents, you get the same thing. All right, now trying the bottom example here, distributing, I'm going to get w 6 times 4, remember multiplication, z to the negative 3rd power times 4, simplifying, that's going to be w to the 24th power, z to the negative 12th power. Now remember, we don't like negative exponents, so this guy right here is going to hop down to the bottom, so I'm going to get y to the 24th all over z to the 12th, and then I am done. All right, now, whenever we are dividing, it's like subtracting the exponents, okay? So whenever we have a division problem, we are actually going to be subtracting the exponents. So, looking here, 3 to the 3rd power, 3 to the 1st power. Notice 3 and 3, same base. They have to be the same base, okay? Or else you can't do this. So they have to be like terms. So 3 to the 3rd, 3 to the 1st, I subtract. That's 3 minus 1 equals 3 to the 2nd equals 9. Now, I want you to see why this works. 3 to the 3rd means 3 times 3 times 3, right? 3 to the 1st means just 1 3. Now, 3 divided by 3, 3 divided by 3, those guys go away, right? Because they go out and they just leave you with 1, which means I have 1 times 3 on the top, which is 9, and then just 1 on the bottom. So notice we end up getting the same answer there. Now, y to the 3rd, that's like saying I have 3 y's, right? All over y second, so that's like having 2 y's. Now notice again that these y's will cancel out, and I'll be left with 1 y. Well, the same thing happens if I just subtract. 3 minus 2 gives me y to the 1st, which is exactly what I want. All right, let's try this next one. R to the 13th over R to the 13th. Well, if I were to do 13 R's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all over 13 R's, I want you to see that they all perfectly line up. Okay, so crossing them out, crosses out with that guy, these guys cross out, these guys cross out, these guys cross out, these cross out. All right. Oh, I have nothing left. Now, nothing left, what does that mean? Well, that means everything divided out and just left me with 1. Now, I want you to look, though, because 13 minus 13 is 0. So r to the 0 power is 1. Now this is always going to happen. What I just showed you here will always happen when the exponents are the same. Therefore, anything to the 0 power equals 1. So it doesn't matter what I have. If I had x to the 1 million power over x to the 1,000th power, so x to the 1,000 over x to the 1,000, it doesn't matter. When I do that, 1,000 minus 1,000 is 0, and I will always get 1. Okay, so anything to the 0 power is always 1. It doesn't matter what craziness is going on. Anything to the 0 power is 1. That's a huge thing to remember. Alright, so now some practice. I'm going to do u to the negative 2 power, u to the negative 12. So I'm going to write every step here just so you can see. You don't always have to do this. So u to the negative 2 minus negative 12. Be careful with that double negative. And then I have r to the first. Remember, if you don't see it, it's a 1. R to the first minus r to the 7. So that's 1 minus 7. And then I get q to the third over q to the second. So that's q to the third minus 3 minus 2. Simplifying, I'm going to get u. Now, these guys, negative and negative make it positive. So negative 2 plus 12 leaves me with positive 10. And then simplifying r's, I'm going to get negative 6. And then simplifying my q, I get positive 1. Now, we're not done because we never have a negative exponent. So that's going to be u to the 10th, q all over r to the 6th. Okay, simplifying the bottom here, I get s to the 8 minus 4, d to the 7, be careful again with that double negative, 7 minus negative 4, y to the 3 minus 3. Now remember, you don't have to show this step here. This is just so I make sure you can see everything that I'm doing. And then 7 minus turns into a plus and a plus. So I'm going to get 7 to the 11th power, y to the 0 power, but I'm not completely done because remember, anything to the 0 power is 1. So final answer is s to the 4th, d to the 11th. I don't have to write the 1 because we just know that it's there. Alright, so some more practice here. Remember, our order of operations still uphold, so we're always going to do those first. So the first thing I'm going to do is my parentheses. So I'm going to go ahead and simplify these guys on the inside. So remember, whenever you are multiplying, you're actually adding. So that's going to be x to the negative 5th, all to the 4th power. Now, whenever I do that, now I'm going to multiply. So that's going to be x to the negative 20th power. Well, no negative powers, right? So that guy needs to flip over the fraction. So I get x to the 20th. Final answer there. Alright, down here, still do my order of operations. I don't have anything going on inside the parentheses, so I'm going to do exponents first, these guys. So 3 times 3 is 9, so that's 9 n to the 9th power times 2 to the n minus 1. Well, I want you to know that whenever we have just whole numbers multiplied, you multiply the coefficients here because n and n are the same. So 1 times 2 just leaves me with 2. And then n to the 9th times n to the negative 1st is, remember, adding, right? So that's going to be n to the 8th. And then that's it. And I want you to see why that works, because if I were to move this guy to the bottom of the fraction bar in the beginning, I would have got n to the 9th times 2 over n to the 1st. And if I multiply these guys together, I get 2n to the 9th over n. And then you can see by subtracting the exponents, I get 2n to the 8th. So many ways to look at the same problem. Just depends on how your brain sees the problem. Alright, so doing some extra examples here. I'm going to go ahead and simplify the bottom of this fraction first because I have some stuff going on down there. So I'm going to multiply these two coefficients. So 2 times 4 gives me 8. And then I'm going to combine like terms here. I have x's on both sides, so that's going to give me x to the negative first times x squared. Remember, we add the exponents, so negative 1 plus 2 is going to leave me with just 1. So I just get x, y on the bottom. Now simplifying, 3 over 8 cannot simplify. And then x to the second over x leaves me with just 1x on top because I do x2 minus 1. And then y to the second over y leaves me with just 1y on top. So final answer is 3xy over 8. Down here I have a to the negative third, b to the negative third to the 0 power. If you remember the trick, you know that this is just 1 because anything to the 0 power is 1. If you didn't remember the trick, if you tried to distribute through that exponent, well, remember it's multiplication, so negative 3 times 0 gives me 0. So a to the 0, b to the 0, well, that's 1 times 1, which is just 1. So either way, you get 1. Alright, so I want you to go ahead and give it a try. Try these on your own. Please put your answers inside of your notes, and I will check these next time I see you.